Welcome to the deep dive. So today, we're really pulling back the curtain on, well, one of AI's biggest recent headlines.
Yeah, that Meta investment in Scale AI. Huge news.
Exactly. Meta putting in a colossal, $14 billion, and that valuation, just eye-watering, $29 billion.
Right. And on top of that, you've got Alexandr Wang, Scale's CEO, now also heading up Meta's new AI superintelligence lab. Big moves.
It's more than just big numbers, isn't it? It feels like the latest chapter in maybe one of AI's most fascinating and kind of unexpected origin stories.
It really is a landmark moment. I mean, this investment, it signals not just, immense growth for Scale AI, but it points to a profound shift in how the tech giants are viewing AI's core infrastructure.
How so? What's the shift?
Well, it seems like it's about owning the data engine of the future, not just, the models themselves. So our mission in this deep dive is really to give you this shortcut, the inside track, to understanding Scale AI's incredible journey.
From those really early days, Combinator, right? All the way to being absolutely pivotal in training these foundational AI models that are, well, shaping everything.
Precisely. We're going to unpack the key turning points, some genuinely surprising insights, I think, and the strategic thinking that's driving not just the future of AI,
but also how we work, right?
Yeah.
And even global competition. It touches everything.
It really does. So let's start at the beginning. How did Alexandr Wang, who's still only 26, become such a central figure in this, incredibly fast-moving space?
Yeah, how did that happen?
Well, his path into AI was quite unexpected, actually. Even back when he was a software engineer at Quora, this was 2014, 2015, he noticed machine learning engineers were already pulling in higher salaries.
Interesting early signal.
But the real seeds were planted even earlier. When he was just 16, he went to these summer camps run by the Rationality community out in San Francisco.
Because these weren't your average summer camps, were they? I've heard about these, lots of deep thinking about the future, AI.
Exactly. They were, gatherings for incredibly bright teenagers, sure, but they also had talks from figures who became really central to the AI industry, people like Paul Christiano.
Ah, one of the key figures behind RLHF, reinforcement learning from human feedback.
That's the one. Crucial technique. Teaching AI models from human preferences, basically guiding them, not just raw data. Greg Brockman was there too, Eliezer Yudkowsky.
Oh, heavy hitters, even back then.
Yeah. And this exposed Alexander really early on to this profound idea that maybe AI and AI safety were going to be the most important fields of his lifetime.
So with that kind of early conviction, he goes off to MIT, dives deep into AI studies, and then applies to Y Combinator. What was the scene like then? That was around the mini chatbot bubble of 2016, wasn't it?
Oh, absolutely. It was in full swing. You had apps like Magic. Facebook was pushing its big vision for chatbots. Everyone was talking about them. And Alexander and his co-founders' first idea, you won't believe it,
Go on.
chatbots for doctors.
Slight laugh. Chatbots for doctors. Okay, that definitely sounds like a very ambitious, maybe slightly naive young founder idea.
He actually describes it himself as a classic example of young founders' ideas being mimetic. Everyone kind of has the same ideas floating around.
Right, following the trend.
And they lacked what he calls a sense of alpha, that unique insight, that edge that only they had. They admitted they knew nothing about doctors. It was just something that sounded expensive. They were, as he puts it, quite lost mid-batch at YC.
Okay, so they're kind of floundering a bit. But it was during that chatbot craze that they had the key realization, the spontaneous idea that changed everything.
Yes, exactly. They just observed that, to build these chatbots effectively, you needed just tons of data and, critically, a lot of human elbow grease to clean it, label it, get it ready.
Oh, the unglamorous part.
The really unglamorous part. And the insight was clear. What if they just provided that data? Instead of building the chatbot application, they'd build the essential infrastructure for it, the road, not the car.
And the pivot was incredibly fast, wasn't it? I read he bought the domain scaledippy.com one night.
And they launched on Product Hunt just a week later. Crazy fast. And that tagline they used, an API for human labor, that really caught people's attention in the startup world.
Yeah, I remember that. It sounded different, almost futuristic in a strange way.
It did. He called it a weird form of futurism because it flipped the usual script. Normally, humans use machines, right? Here, it was humans doing work for the machines. It was provocative.
And it worked. Got them traction.
Enough. It generated enough early buzz and customers from Product Hunt to help them raise some initial money and, get the wheels turning.
But the really, really pivotal decision came a bit later, right?
Mm.
When they decided to focus exclusively on self-driving cars. I bet that raised some eyebrows. Investors must have thought the market was way too niche.
Oh, absolutely. He said their lead investor flat out told them it was obviously way too small a market to build a gigantic business.
But they stuck to their guns.
They did. They had conviction. And then Cruise, which was another YC company, found them and pretty much overnight became their largest customer. Huge validation.
Wow. Okay, so that proved the focus wasn't crazy.
Right. It allowed them to build the business very quickly. But, while it accelerated growth, he acknowledged later that long-term, just self-driving probably wasn't enough to sustain a gigantic business.
Right, makes sense. So that initial success with self-driving was key, but clearly not the end game for a company with their kind of ambition. What was the next big wave they caught, and how did they even see it coming?
Yeah, that's where the evolution of AI itself really becomes central to their story. In that self-driving era, engineers were mostly limited by the compute power on the car.
Right, edge computing constraints.
Exactly. So they weren't really thinking about what we now call scaling laws. They were just, grinding algorithms to try and fit them onto the hardware. But then things started to shift around 2019. Scale AI began working with OpenAI. This was during the GPT-2 era.
Okay, so getting involved with the big language models early, and that's when the penny started to drop about scaling laws. Can you just remind us, what exactly are scaling laws in this context?
Sure. Simply put, scaling laws showed that if you just threw more compute power, more data, and bigger models at the problem, you got predictably better performance. It wasn't just about clever algorithms anymore. Scale itself became a dominant factor, a fundamental shift.
And GPT-3 in 2020 was the moment it became undeniable.
Yeah, GPT-3 made the concept clearly felt very real, as Wang puts it. He tells this great anecdote about playing with GPT-3 in the OpenAI playground with a friend.
Oh, yeah.
And during the conversation, his friend got visibly frustrated and angry at the AI. Not just like, oh, this is wrong, but in a somewhat personal way.
Whoa. Frustrated at the AI, personally.
Yeah, it wasn't just a toy spitting out text anymore. It felt somehow like a conversational partner you could actually get annoyed with.
That's a really visceral reaction that suggests something shifted, didn't it? The kind of qualitative difference.
Absolutely. He said it showed a semblance of passing the Turing test. Now, while GPT-3 was highly interesting, the real mainstream aha moment for generative AI probably came later.
With DELI and then ChatGPT.
Exactly. DALL-E first, then ChatGPT in late 2022. Though Scale had worked with OpenAI on its precursor, InstructGPT, those were the moments that brought generative AI into widespread public consciousness and really solidified Scale AI's strategic direction.
And then came GPT-4.
Yeah.
That really hammered home the point about scaling laws being real, right? And this idea that the need for data will basically grow to consume all available information and knowledge that humans have.
Precisely. And that's where the NVIDIA for data analogy comes in. If NVIDIA provides the picks and shovels the compute scale, AI sees itself providing the essential fuel, the gold itself, the data.
But mining that gold, getting high-quality data at that scale, that's the massive challenge, isn't it?
That is the challenge, and that's their core expertise. Building the data pipelines, the quality control, the human workforce infrastructure. And GPT-4 was significant because it was really the first time a model could achieve, in his words, zero hallucination, but only in limited, well-defined domains.
Meaning it wouldn't just make stuff up if you kept it focused.
Right, if the context was narrow and the data was good. And that really shifted the focus onto how high-quality data and careful context are absolutely critical to prevent models from going off the rails and making them actually reliable.
So it's not just about throwing more raw data at pre-training anymore. He talks about a new scaling curve of reasoning and reinforcement learning that's proving shockingly effective.
Yeah, it's like there are multiple S-curves to IDGS stacking up. The improvements we're seeing now aren't just from bigger base models, but from these sophisticated training techniques like RLHF, refining the model's reasoning and alignment.
Almost like Moore's law, maybe. Even if the underlying tech changes, the overall improvement feels smooth and continuous.
That's a good analogy. And this leads to a pretty provocative idea he has about the future. He thinks that soon, every firm's core IP is actually their specialized model or their own fine-tuned model.
Whoa, so instead of just code bases being the unique asset.
Right. It'll be the AI model itself, trained on your company's specific, gritty, real-world information,
Hmm.
using specialized data, specialized environments to give your AI capabilities that no one else has.
That really brings us a huge question, doesn't it? Does AI or AGI just become this giant Borg that swallows the whole economy?
Hmm.
Or do we end up with a specialized economy where AI is more of a powerful tool within different niches?
It's a massive question, and Alexandr Wang definitely leans towards the specialized economy view. He doesn't see one giant AI taking over everything.
Okay, why not?
He thinks models will primarily act as platforms, and the real alpha, the competitive edge, will come from a company's ability to effectively translate their unique business problems, their domain knowledge, into data sets that can train differentiated AI. It's about infusing the AI with your specific context.
That makes sense. So it's less about one general intelligence, more about countless specialized intelligences tailored to specific tasks and industries.
Exactly. And this all points towards, well, a fundamental shift in how we work. As he says, we are undeniably at the beginning of a new way of working. Work itself fundamentally will change.
And he seems pretty optimistic about it, despite all the anxieties you
It
hear.
really does. He stresses that humans own the future and that we have a lot of agency in shaping how this transition happens. It's not predetermined.
Okay, let's dig into that. He uses coding as a case study, which is a great example because we're already seeing changes there.
Right. He breaks it down into stages. First, you have the assistant-style models helping humans here and there, like co-pilots suggesting code snippets.
Yeah, we're mostly there now. What's next?
Then he sees cursor agent mode. This is where humans are almost pair programming with a single AI agent, actively telling it to carry out specific workflows, generate larger blocks of code, refactor things more synchronously.
Okay, a much tighter loop.
Yeah.
And the final stage.
The final paradigm, he suggests, is managing a swarm of agents. So the human role shifts to becoming like a manager, overseeing a cohort of agents that are deployed on various tasks.
Interesting. So the terminal state of the economy, as he puts it, is large-scale humans manage agents.
Yeah. And he directly pushes back against the more doomer view that agents will just manage themselves entirely.
Why does he think humans stay in the loop?
Because management, he argues, is just very complicated. It's not just assigning tasks. It involves setting vision, constantly debugging problems, putting out fires. It requires judgment and context that current AI lacks.
He uses that self-driving car analogy again.
Exactly. Getting to 90% autonomy is one thing, but that last 10%, getting to 99% or 99.9% is very, very hard. It requires human oversight, human intervention, like the remote assist operators for autonomous vehicles.
Where you might have one human overseeing, what, 3 to 5 cars?
Something like that.
Yeah.
His point is humans are much more involved in making these complex systems actually work reliably than we often appreciate.
So if humans are managing agents, what does that mean for jobs overall? Does this techno-optimism account for potential displacement?
His core argument there is rooted in human nature. He says for low unemployment, basically, you just have to believe that humans are like almost insatiable in their desire and their demand.
Meaning as things get cheaper and more efficient thanks to AI.
We'll just want more stuff, more services, new kinds of experiences, things we can't even imagine yet. He sees this as a reliable pattern throughout history. Efficiency gains don't lead to mass unemployment long term. They create new demands.
It's a compelling historical point. He draws that analogy to the word computer itself, right? Which used to refer to a person doing calculations.
Yeah, it's a great analogy. Just like early programmers gained this incredible leverage boost, he likens it almost to alchemy, creating infinite, perfect replicas of their work with code. He believes the entire human workforce is on the cusp of seeing a similar massive leverage boost.
Across all fields, not just tech.
Across all trades, he argues, enabling shockingly productive outcomes everywhere. It's about amplifying human capability on a massive scale.
That ties back to Scale AI's own journey, doesn't it? This idea of building ahead of the curve, anticipating the next leverage boost. How have they managed to do that so consistently?
It really seems to be their MO, consistently building ahead of the waves of AI. Look at the examples, working with OpenAI on language models way back in 2019.
Before the hype really took off.
Exactly. Engaging with the Department of Defense on government AI applications in 2020. Supporting enterprises with AI data needs long before the larger waves of adoption really hit the mainstream. He compares this kind of foresight to someone like NVIDIA's Jensen Huang. You have to anticipate where things are going years in advance.
So what was the next big strategic anticipation? And he talks talks about a pivot around late 2021, early 2022.
Yes, moving towards building AI-based applications and agentic workflows, specifically for large enterprises and governments. And he says this was actually inspired by Amazon's move into AWS.
AWS. How so? That seemed like a totally different business for Amazon initially.
Right. He said analysts at the time thought AWS was nonsensical for a retailer. But the underlying wisdom, he argues, was twofold. First, the conviction that cloud computing was an infinitely large and growing market.
Okay, huge potential scale.
And second, the massive cost advantages they could get from economies of scale by building it out themselves. Scale AI saw a parallel.
For AI applications.
Yeah, they had this realization that every business and every organization was just going to have to reformat their entire businesses with AI-driven technology. That identified another potential infinite business opportunity for them.
Which was building out those AI applications for these large organizations.
Exactly. Focusing on top-tier clients, big pharma, telcos, banks, healthcare systems, and significantly, the U.S. government.
And this is now a big part of their business.
Apparently, yes. A multi-hundred-million-dollar AI application business. And crucially, he says it's directly fueled by their existing strength, their differentiation in the data business.
So they use their data expertise to build better applications.
Right. They can apply all that wisdom gained from preparing data for foundation models to help these enterprises build highly specialized applications that are deeply infused with the company's unique proprietary data. That's the key differentiator.
It sounds, at a high level anyway, a bit like what Palantir does, serving large, complex organizations with data and AI solutions.
Yeah.
Is that a fair comparison? Is it competitive?
He acknowledges the comparison but argues the market is just so vast, infinitely large, and so greenfield that they feel more partnered than directly competitive with companies like Palantir right now.
Interesting. Too much work to go around.
Basically. The problems are so massive, he says, that the real bottleneck isn't competition, it's talent. Finding enough skilled people is the true limiting agent. He hopes this explosion in agentic leverage might eventually help alleviate that constraint.
Speaking of agentic leverage, how much are they eating their own dog food? How is Scale AI using agents internally?
Quite extensively, it sounds like. Because they were producing all these data sets for model developers, they saw firsthand just how effective reinforcement learning was for training agents. Pretty insane efficacy, he called it.
So they started applying it to their own processes.
Exactly. They began converting their own repetitive internal workflows, things that humans were doing over and over, into environments and data for reinforcement learning.
Like what kind of workflows?
Things like aspects of hiring, quality control processes, data analysis tasks, even sales reporting. He gave a specific example of using agent workflows, he called them deep research plus C agents, to distill lengthy candidate application packets down into concise briefs for hiring managers, dramatically speeding things up.
So moving beyond just simple prompting, using RL for internal tasks.
Yeah, he makes the distinction. Prompting gets you to a certain level, but reinforcement learning gets you beyond that level for more complex, reliable automation. Though he admits for many internal things, just good prompting works really well.
Okay, shifting gears slightly, one of the really fascinating projects they're involved with is Humanity's Last Exam. What is that? It sounds dramatic.
It is a bit dramatic. It's an evaluation benchmark they built in partnership with the Center for AI Safety, and it's essentially a data set composed of stupidly hard scientific problems.
Stupidly hard how?
These are problems contributed by top researchers, problems that have never appeared in any textbook or likely even online training data. They require deep, multi-step reasoning, not just pattern matching or looking things up on the internet.
And how are the models doing on it?
The progress is pretty remarkable. When they launched it earlier this year, the best models were scoring around 7–8%. Now, just months later, they're scoring over 20%.
Wow, rapid improvement on genuinely hard, novel problems. What about the name Last Exam?
He calls it the saving grace of the name. The idea is that benchmarks like this eventually saturate models, get too good at them. So this is framed as maybe the last exam of its kind before we have to move to evaluating AI on much fuzzier, complex, real-world tasks.
And the very existence of evaluations like this, it pushes the whole field forward, right?
Absolutely. He says popular evaluations become the North Star and the yardstick that researchers are trying to optimize for. It focuses effort, leading to models that become deviously good at tackling these frontier problems.
Which leads to a pretty mind-blowing prediction he makes about actual scientific breakthroughs.
Yeah, this is bold. He predicts that we will see new scientific breakthroughs coming directly from AI-driven reasoning and these models within the next 12 to 24 months.
Not just assisting scientists, but making novel discoveries.
That's the implication. He uses biology as a prime example, suggesting models will develop intuitions that humans don't even have. He points to things like AlphaFold in chemistry.
Right, the protein folding breakthrough that won a Nobel Prize.
Exactly. That showed how AI could just destroy previously abysmal problem-solving rates in certain scientific domains. He paints this picture of an exciting time for science, where maybe a large part of a scientist's job becomes trying to understand the discoveries the AIs are making.
That's a profound shift in the scientific method itself. Looking outward now, though, we have these incredible capabilities emerging.
Yeah.
How does this play out geopolitically, particularly U.S. versus China?
Yeah, this is a huge focus for him. He confronts what he calls the awkward reality that right now, arguably, the best open source models in the world come out of China.
Really? How does he explain that, given the U.S. lead-in foundation models like GPT-4?
His simplest explanation, as he puts it, is espionage. Basically, secrets, the tacit knowledge, the hyperparameter tuning tricks, the engineering know-how leaking out of the frontier labs in the U.S.
Okay, beyond espionage, how does he see the strengths and weaknesses stacking up between the U.S. and China in this AI race?
He breaks it down across several areas. First, energy. He argues the U.S. is very behind on energy production, specifically because of pure regulation. U.S. grid capacity is flat, while China has doubled its production, mostly coal, but still double the energy for AI.
A fundamental constraint for compute? What about manufacturing?
China has incredible manufacturing capabilities, he says, especially for robotics hardware. He gives the example of a robot that might cost $20,000, $30,000 in the U.S., costing maybe $2,000, $4,000 in Shenzhen. That's a huge cost advantage and a very big problem for the U.S., especially for defense and national security applications of AI.
And data. We touched on data earlier.
He believes China has a fundamental data advantage. They can largely ignore copyright and privacy concerns that constrain Western companies. Plus, they have massive government programs for data labeling. He mentions 7 dedicated centers, subsidies, even college programs training labelers, and factories full of robots just collecting robotics data. He even notes some U.S. companies apparently rely on data from China.
Okay, so energy, manufacturing, data seem to lean towards China. What about chips and algorithms?
There, he says, the U.S. is net-net, still ahead on the most advanced compute and chips, and generally much more innovative on core algorithms and model architectures. But he adds that espionage potentially evens it out over time if know-how keeps leaking.
So, overall assessment, who's ahead?
He puts it at maybe 60-40, 70-30, in favor of the U.S. currently. But he's clear there are many scenarios where China could catch up or even overtake. It's not a guaranteed U.S. lead.
Given those dynamics and thinking about defense, what's the implication for national security? How is AI changing warfare?
He talks about a really crucial shift, moving away from the old paradigm of just bigger and bigger bombs towards using smaller, more nimble, attritable resources. Things like autonomous drones, embodied robots, sophisticated cyber warfare. It's a move towards what he calls agentic warfare or agentic defense.
Where autonomous or semi-autonomous systems play a much larger role.
Exactly. And a key part of that is accelerating decision-making. He points out that current military command and control is often remarkably manual and human-driven, working with incomplete information and slow processes.
Whereas AI agents could potentially provide
perfect information or much closer to it and enable immediate decision-making. He gave a specific example of Scale AI's own work with the U.S. Indo-Pacific Command on a system called Thunderforge.
What does it do?
It's apparently transforming critical decision-making cycles from potentially 72 hours down to 10 minutes. He likens the difference to playing chess against a human versus playing against an unrelenting chess computer. The speed and information advantage is overwhelming.
But trust is key there, right? You need to know why the AI is recommending something.
Absolutely critical. He stressed the importance of being able to see the AI's chain of thought. Understanding the reasoning process behind its recommendations is essential for human commanders to actually trust and use the system effectively.
It's clear Alexandr Wang has navigated all this complexity with a really potent founder's mindset. What does he boil it down to? What's his core advice for achieving this kind of success?
It's actually incredibly simple but profound. His most impactful advice is You just have to really, really, really care.
Really care. That's it.
That's the core. He kind of attributes this intensity to maybe the folly of youth, where everything just feels astronomically important. It's about having this deep personal investment in the mission and the outcome.
And that extends to hiring too, right? His philosophy there.
Yeah, hire people who give a shit. Simple as that.
Yeah.
He says you can easily tell the difference between people who are just kind of phoning it in versus those who truly hang on to their work.
People for whom the work feels.
Monumental and forceful and important to them. People who feel real satisfaction when they do great work and it genuinely eats at them when they don't. That deep sense of ownership.
And he leads by example on this.
Absolutely. He apparently cares immensely about pretty much every decision, big or small. He even reviews every single hire personally. He believes this deep investment, which he tries to instill in his team, allows them collectively to feel much more deeply what happens in the business.
Which lets them do what?
Yeah.
Adapt faster.
Exactly. Lets them change course more quickly, learn more quickly, and ultimately adapt more quickly to the incredibly fast-changing landscape. Because they care so much, they feel the signals sooner and more strongly.
So what does this deep caring mean for the quality of the company's output, its products, its services? He uses this phrase, quality is fractal. Can you unpack that a bit?
Yeah, it's a great concept. Think of a fractal pattern like a snowflake, where the same intricate detail repeats itself whether you look at the whole thing or zoom way in.
Okay.
So quality is fractal means that when the leadership, when management truly and deeply cares about standards, about excellence, that intense focus doesn't just stay at the top, it cascades down. It gets mirrored in every team, every process, every individual's work, right down to the smallest details.
So that deep desire to need to care, as he puts it, permeates the entire organization.
That's the idea. It creates this self-reinforcing culture of high standards and meticulousness at every level, leading to that fractal quality where excellence is just embedded everywhere.
Wow. What an incredible journey we've really unpacked today. I mean, from that tiny YC startup with the slightly misguided chatbot for doctors idea.
Right. All the way to being this major multi-billion-dollar player that's genuinely shaping the future of AI, the future of work, even global strategy. Scale AI's story is really one of, well, foresight, adaptability, and just this relentless commitment to tackling the core challenges of AI at scale.
Absolutely. And as we wrap up, thinking about everything we've discussed, the sheer speed of AI advancements, the way work is being redefined, the intensifying global competition, it leaves you with a lot to consider.
Definitely. Perhaps the final thought for you, the listener, is this. Given everything that's happening, how will you leverage these powerful new AI capabilities to shape your own future, your own work, your own industry? What role will your unique human demand, your unique needs and desires play in this rapidly evolving economy?
And maybe even what new challenges, what new questions will we all need to grapple with as AI potentially starts making scientific breakthroughs all on its own? Lots to think about.